Here is an example problem from 6.4, and it is dealing with finding the confidence interval for the population variance and the standard deviation. And it already gives us a confidence interval of 0.98, standard deviation of 35, and n is equal to 20. Now the first thing I'm going to do is make sure that I'm using the right formula, so I'm going to your key formula chart. And notice down here the formulas we have for finding our variance and for the standard deviation. Once you have the variance, notice that all you're doing is taking the square root to find the standard deviation. So we're going to be taking n minus 1 times s squared all over chi-square right. And over here it's the same thing on top, only we divide by chi-square left. Now the problem gave us n is equal to 20, so I know this is just going to be 20 minus 1. And it gave us the standard deviation of 35, so this value is just going to be 35 squared. So I'm going to end up with 19 times 35 squared on the top on both of these. The only thing I'm going to have to worry about is where to find these guys, the chi-square right and the chi-square left. For that, we're going to go to our chart, our chi-square distribution. And this thing, it looks a little complicated, but if you notice, well, first of all, up here, when you're dealing with the chi-square distribution, instead of like the normal chart where your area is to the left, your area is actually to the right. So on the problem that you had, it had 0.98 for a confidence interval. So that is right in here, 0.98. If I take 1 and subtract 0.98, that gives me 0.02. That has to be spread through both of these little tails. So I'm going to take 0.02 and divide it by 2 so that I have 0.01 in each tail. So that's going to be 1 minus 0.98, the confidence interval, is 0.02, and now I have to split that amount up so that it's equal in each tail. That's the number I'm concerned about from the chi-square chart. All right, so I look on chi-square chart and it has a column for 0.01. Now this is like the t-chart. It uses degrees of freedom. So instead of using n, I'm going to be using n minus 1. Since we had n is equal to 20 in our problem, I'm going to go down to the row 19. 20 minus 1 for 19. All right, I'm just going to cover up below that so it's a little easier to see this. All right, so here we have 19. I follow that along, and moving this over, I have 0.01 gives me 36.191. That would be my chi-square right. Notice that this is 1 in on this side, so I know that I'm going to be looking for chi-square left, 1 in on this side. So my other chi-square is 7.633. And notice if I have 0.98 in the center, 0.98 and 0.01, that'll give me a total of 0.99 to the right of chi-square left. So I look under 0.99 and I get 7.633. So these are the two numbers that I'm going to be using in my formula. So now I go back to my problem and I looked up these chi-square values. I'm going to substitute them into that problem, and when I evaluate it, I'm going to end up on my calculator with these values. And sorry about that glare, I'm going to try to block it here. 19 times 35 squared divided by my chi-square right, and then 19 times 35 squared divided by my chi-square left. Now, you are going to have to be rounding this to 2 decimal places, so my answer would be 643.12, and that is my left bound, and 3049.26 would be my right bound. When I go to find the standard deviation, these would be my answers for the variance. And for my standard deviation then, I would just take the square root of 643.1156,917. Just to make sure I don't screw up a rounding error, I want to make sure I put that whole thing in there. So this would be my left bound on my standard deviation, and then I would take the square root of the next value, 3049.259793, and that will be my standard deviation for the right bound. And that is about all there is to that one. You know, keep these simple. The hardest part is actually just looking them up on the chart.